Assalamualaikum everyone. My name is Samir Islam, and this is our these are our group members. And as you can see, our topic is right over here: turning Dhakas traffic into power. This is our topic. So, so today I'm gonna give you a little briefing about how we're gonna turn Dhaka's traffic into power. So, how can we turn Dhaka's traffic into power? As we know, like Dhaka is one of the world's most congested cities, right? It's like we're sitting on traffic. We are like we- so many people are commuting from in and out. Like from Gulshan, from Banani, etc. Like that's like the one of the major office hubs, right? So basically, so many people stuck in traffic. But how can we, instead of seeing it as a burden, how can we use this dilemma within the entire Bangladesh? That okay, since most of the cars are stuck in traffic, why don't we create a sensor which like the briefing details about the sensor will be discussed by my other group member. So basically, what would we do is that we would set sensors in all of the basically in like major part of like of the roads where like majority of the traffic happens. Like let's say Bijeshwarani or Farmgate, Noakhali, etc. We're starting off with these three, and then we're gonna slowly expand. So basically, so as you know, like now we have another question: like, what if the movement itself could become a renewable energy source, right? That's a very good question. The thing is that the entire presentation, the entire presentation just explores like it harvests mechanical energy from traffic using piezoelectric and motion-based systems, and we use that to power the local infrastructure. Okay, the paradox. So like now we're gonna talk about the paradox. The entire paradox of Dhaka, which is the wasted motion. Now the key realities. Like, unstoppable traffic. Millions of like we all know that millions of vehicles like move around Dhaka city every day, right? Now, but here's the thing: we don't realize that there is like so much wasted mechanical energy, vehicle weight and more, and like so like what it's gonna happen is that a vehicle weight in motion, they're gonna apply large forces, and they're gonna create a pavement which currently just like necessitates like more and more heat and vibration. But due to that, there's gonna be like very persistent energy shortfalls. Now, because here's the major advantage we don't know is that the Dhaka faces very frequent electrical stress due to like despite abundant mechanical activity, and due to that, we can create. Now imagine, like, can we capture? Now here's the thing. The question is, can we capture that lost mechanical energy and turn it into reliable electricity within the street level use? The question, as you can see on the slide, the question is yes. Imagine, like, if we put on sensors within like the traffic hubs of the city. So like even like one squeeze within one, like a squeeze within one car won't be enough. But imagine thousands and thousands of cars, like millions and millions of cars across the entire Dhaka city, like slowly. Like just imagine like slowly, like let's imagine thousands of cars within Dhaka. Let's start with Dhaka. Like thousands of cars giving a squeeze while they're stuck in traffic. Like you just imagine how much energy, how much electricity we can generate into power. It's gonna be remarkable. I hope with this initiative we can take Bangladesh to a whole new level. So, and briefings about the sensors and what is fiber electricity will be shared with my other members. Thank you very much.
In this slide, we explain what piezoelectricity is and how it is used to generate electricity from road traffic. Piezoelectric materials produce electric charge when a mechanical pressure is applied. Simply put, when a vehicle passes over the road, the pressure on the immediate sensors create voltage. Materials like special ceramics and quartz make this possible. The process works step by step. First, piezoelectric sensors are embedded beneath the road surface. When vehicles move over them, the pressure generates alternating current AC. This AC is then rectified and regulated into a direct current using a converter. The electricity is stored in a 12-volt deep cycle battery, which can handle frequent charging and discharging. Finally, this stored energy is used to power streetlights, traffic signals, and other nearby systems. So everyday traffic is converted into a useful and reliable source of electrical energy.
It is where to deploy target zones in Dhaka. So this slide highlight where we should deploy this system in a Dhaka. We focused on high traffic areas where vehicles frequently slow down as the maximum energy generation. In this location including Farmgate, Vijayashwarni and Mohakali. So these areas known as heavy generated traffic and constitution different vehicles. By installing electric roads is in these zones, even 1 kilometer can generate enough power for street light traffic signals storage. And this makes urban infrastructure more suitable and energy efficient. So we can storage many energy in these areas. Thanks for everyone. Our project utilizes a comprehensive technology stack to transform everyday road traffic into a reliable, sustainable power sources. We start with piezoelectric sensors embedded in the asset, which use durable ceramics to convert vehicles comprehensive into AC voltage. Our electromagnetic harvester leverages suspension and movement to capture kinetic energy, while speed breakers generators harvest power from vehicles at crossways. Finally, our power conditioning and storage system utilize rectifiers, DC-DC converters, and battery banks. Stabilize this harvester energy, ensuring it is ready to supply direct local grids or local. Thanks for everyone.
Hello, Assalamualaikum everyone. My name is Ghulam Master Fude. Today I will talk about the benefit of this system. The first one, clean and renewable. It means it can be generate electricity without any pollution or fuel consumption. It can work with solar and wind energy to make our city's energy system more reliable. Another important benefit is smart city integration. Here, roads are just not for transportation; they can also produce electricity. They can also produce energy for street light, traffic signals, and sensors. It also improves resource efficiency. Traffic is unavoidable in our cities, so instead of concentrated energy, we convert it into a useful electricity. The next, the next part is challenges and technical risks. The first one is cost. If we apply this project on roads, we need a high initial investment. So we need proper funding are necessary. Next is maintenance. Since the system is placed on roads, repairing or replacing part can be difficult. There are also issue is efficiency and energy yield. Each unit produce a small amount of energy. So we need a large scale implementation to make it effective. The last one, cost chart. So if we if we complete this project, we need this equipment. The first one, solar PV panel 1 unit, piezoelectric sensor 50 units, breeze rectifier 1 set, and solar charge controller 1 unit, energy storage 1 unit, protective casing 1 set, and lastly wiring accessories 1 set. So we make this project. Our total cost is 1900 Taka BDT. So this is my part. Thank you.
Assalamualaikum. I am Abir Hossain, ID 25623352. Today I will show how to Dhakas traffic can transform a problem into an asset. Let's look at some example from around the world, then discuss the possibilities for Dhaka. Small pilot projects in different countries have been successful. For example, pilot road tiles installed in high footfall areas are powering lights and signage. Speed breakers generator are providing micro electricity for sensors and street lamps. And hybrid system which combined piezoelectric with solar smooth out supply variability. Now let's think about Dhaka. We can start small scale pilots in presence like farmgate or bus terminal. There we can test how much energy we get, how durable the systems are, and how people access them. If everything works well, we can roll it out across the city. Next part is conclusion. In conclusion, the pressure and vibrate of Dhaka's traffic is a measurable and reliable source of energy. With small design, intelligent battery storage, and phased piles, this piezoelectronics and motion harvesting system can power local lights, signals, and sensors, and reviews stand on the grid. Finally, three key thoughts. One, think differently. Traffic is just not a problem, it is an asset. 2. Design practically. Smart, small, measure then improve. Prioritical, just and durability. 3. Scale responsibility. Integrate with storage and other renewable to make a real contribution to Dhaka's energy needs. Thank you. Thank you everyone.